All right. Good morning, sir, or good afternoon. Hi, my name is Iyad, and I'm here with my Group 31. Me, Yanashmi, my friend Wei Yan, and my other group mate, friend to Junkit. So today we're going to present about our assignment one, our database security. So I'm going to pass it first to Wei Yan to explain about the system.
Hi sir, so now I'll present about the outline of the system. So our project aim to develop a secure SQL-based database system designed to manage the event efficiently while ensuring robust security measures. The object is to safeguard enterprise data from unauthorized access and breaches. This system provides core functionalities like user registration, login, and event management while ensuring separation of role between user and admin for enhanced security. Next slide. So this system caters to two types of role, that is admin and the user. For the user, the system offers a streamlined process for registering and managing the event. They can view the event in a calendar format and perform action like adding, updating, and deleting event. For admin, there is a secure dashboard to manage all event, edit the event detail, and the oversee user activities. So now I'll pass to Junket to present about the threat modeling.
Hi, I'm Jinggit. So I'm now present the threat modeling. Okay, so now I start with threat analysis. The threat analysis reveals that our application has low overall risk due to strong security measure. So in threat analysis have spoofing, tampering, repudiation, information disclosure, DOS, denial of service, and elevation of privilege. Okay, so spoofing is mitigated through hash, password, and session-based access control. So in this table, it is lower in the metric risk level, and while tampering is prevented with input validation and sanitization. Okay, so it is also low. Okay, so repudiation risks are addressed by linking all actions to authenticated sessions for accountability. Okay, so repudiation also low, and information disclosure is minimized by hashing sensitive data, restricting access, and using secure error handling. Okay, and denial of service DOS is mitigated through basic input validation that blocks malicious payloads. Okay, and elevation of privilege is prevented using strict role-based access controls. This combines measures ensure robust protection against potential threats. Okay, so that's low for repudiation, low for information disclosure, and moderate for denial of service, and low for elevation of privilege. Okay, so next I'll talk about the threat analysis. Okay, so the threat analysis highlights that our application poses a low overall risk, while damage potential is moderate with risk of data tampering or exposure. This is controlled through password hashing and role-based access. All right, so the damage potential is 2. Okay, overall score, average score. So we have separate to admin login, user login, event management, and logout. Okay, so the average score is 2, and reproducibility is low due to secure authentication and query handling, and exploitability is also low, requiring attackers to bypass strong validation mechanism. Okay, so here the reproducibility is 1.25 and the exploitability is 1.252. Okay, so the number of affected users is moderate, encompassing both admins and users, but robust safeguards reduce the impact. Discoverability is low as sensitive data is protected by secure error handling and sanitized output. These measures collectively minimize the likelihood and impact of security threats. Okay, so affected users is 2.25 and discoverability is 1.25. So that's all for my threat modeling. Now I pass to Wei Yan to talk about the PDPA 2010.
Okay, so we align our system with the PDPA 2010 to ensure the compliance with the data protection laws. We identify the admin as a data user responsible for managing and safeguarding user data, while the user are the data subject whose data is collected and processed. At each stage of the data lifecycle, we implement measures like SSL encryption, secure storage with SQL Server TDE, and minimal data visualization to prevent the overexposure. Any non-compliance can result in several penalties, fine up to 300,000 or imprisonment for up to 2 years. So that's all my part. I will pass to Iya to present about the implementation.
All right, so I'm going to be presenting about security implementation. So one of the first security implementation that we have implemented into the system is an audit trail. So this audit trail logs all of the successful logins, the failed logins, as well as the accesses to the multiple schemas and of the objects. And then next we have TDE. So we have enabled transparent data encryption in our SQL, in which we encrypted the master key. We use the password to encrypt the master key, and then create a certificate. Then use that master key in order to create in order to set the TDE for the database. Then for our coding, for our PHP, we have implemented SQL injection protection, and that is by using statements, the STMT. So we use parameterized queries. So instead of directly querying into our database or system, we use a parameter to block the SQL injection attack that could be done. Then for our users, we have created two different logins or connections. One is admin login for the admin, and other one is user login for the users. So, for example, in our system, admins are only allowed to modify the user table and events table, while the user can only modify the events table and only write to the user table. So certain pages will use user logins and certain pages will use admin login. And then the final one is password hashing. So for both of our users, we have used hashing in order to protect the password on top of the encryption. So for example, if you look at the pictures, on the top one, it is hashing the admin password and saves it as var binary and saves it into the admin table. As you can see on the third picture, you can see the password is in hex. Is in binary. Then for the users, we just use the password hash function that is included into PHP in order to insert and also verify whether the password is correct or not. So now we will show how our system works. So for example, if I were to enter a user, then we can see the calendar. So this is the current day. So this is the event. I can add a new event. For example, event. For example, it's happening tomorrow until the next day. And then we add the event, and then we can see it right here. This is an event added. We can sort everything out in weeks or days or months. We can go to the event and we can edit the event details as we want. See it added. We can also delete the event if you wanted to. Delete this one. So it's gone. So this is the basic usage for the user side. So then this is a register. So all of these have been protected from SQL injection by using parameterized queries. So now we're going to go to admin login. So admin login and admin account can only be added through SQL. In the future, there will be a way to register admins, but as of current now, we only have one admin. So, as you can see, if you enter the wrong credentials, it will say this. So here you can see all the different events. You can see the user, what the title is. For example, this one we just added just now. We can edit. We can edit the details for the user. We can also manage users, where we can delete the users, or we can set the status to active or inactive. Inactive wouldn't allow them to log in. And then that is basically all for the system. Thank you very much, sir, and thank you.